Well, those values are on our unit circle. 120 is also on our unit circle. We're just practicing it. So real quick, what's the sign of 120 if you look at your unit circle, or if you know it offhand? And it should be positive, right? Because we're in quadrant 2. So this should come out to that exact same value. Let's see, make sure it does. So we have 2 times, now the sine of 60 degrees. 60 degrees is our third tick mark. That is going to be square root of 3 over 2. The cosine of 60 degrees is going to be 1/2. However, kind of you want to simplify this, we could do this multiplication first. So we could turn that into 2 times square root of 3 times, bless you, is square root of 3 over 4. But we're going to note this 2 and this 4 are going to kind of cancel out, not completely with the 4, but the 4 is going to turn to a 2. And we're going to be left with square root of 3 over 2. Was that what we expected? Yeah. As long as you put it in right, we should get that exact same value out. Now, we're going to do the exact same thing, but with a half angle identity. If you look at your homework actually doesn't tell you which ones to use. Your job is kind of write it out and see if it's going to come up with unit circle values. So plug it in the double angle. If it's something on the unit circle, we can use it. And then if that doesn't work, use your half angle. I would try to use the double first and then look at your half angle. All right, but a half angle. Now note, I need something divided by 2 to give me 120. No longer is this going to be 60 degrees, because if I'd put a 60 degrees up here, I would actually have it equaling 30. So we actually need to double it before I half it. Yeah, sorry. Stole it from you, didn't I? Yeah, it's going to be 240 degrees. Note, once again, this is the identity. This is the angle you're putting in. So the most important part about this is that 240, because we should already know that goes to an identity. Now our half angle identity actually has a positive or negative in it. So it's actually positive or negative square root of the 1, and this will be minus cosine of 240 divided by 2. We need to be able to figure out if it's positive or negative by the original angle. What quadrant is 120 in? Quadrant 2. Is sine positive or negative in quadrant 2? Positive, so we would choose the positive version of this quadrant 2. Easy enough here because we already know what the answer should be. It should be a positive square root of 3 over 2. All right, let's continue on. So now that we have a positive, I'll just leave it off. So we're going to have 1 minus the cosine of 240 is going to be, anyone know what that is offhand? 1 over 2, and it's going to be negative because, yep, negative 1 over 2 over 2. So that means we are, in fact, adding. So that would actually turn this into a plus-plus situation. Well, that's going to equal, well, picture 1 as being 2 over 2, and that's going to give us 3 over 2 over 2. We can either use keep, change, flip if you want to, or we could just multiply the top and bottom by 2. That was that trick that I was showing you in the last unit. That if you ever want to get rid of a fraction in a numerator or a denominator, just multiply by the denominator. You're going to need to know how to do this. We're going to get to really complicated ones that this is the only way that it's going to work. Where keep, change, flip isn't going to help because we have too much stuff going on. So we need to realize that this, in fact, works. Just multiply by a denominator, and that's going to clear that fraction out as long as you do it to the numerator and denominator. So that's going to leave us with a 3 in the numerator and a 4 in the denominator, and that's going to end up being a square root of 3 over 2. Once again, if I have my choice, I'm going to lean towards double angles. They're typically easier ones because they don't have those square roots in it. but there are going to be times where you're forced to use a half angle. And we'll see that on the next two examples. All right, all good? Well, all my steps, I'm starting to kind of skip stuff, so let me know if you're not sure of a step. Put extra notes to yourself. If you're just like, oof, I'm not there where I'm going to skip steps, write everything down. Yeah?
What do you do if the original angle you have isn't on your circle? Like, how do you know if it's positive?
You're going to have to figure out what quadrant it would be in. So your goal is, think of your key divides. So quadrant 1 and 2 are divided by pi over 2. So if I give you like pi over 12, it's not on your unit circle, but you need to know that's in quadrant 1. That's much smaller than pi over 2. When you start getting into that pi over 2, 3 pi over 2 range, you just got to figure out that number that's in front of it. So here's my advice to you in that regards. So on our unit circle, we have pi over 2 up here, and we would just have pi over here. Now think about what number's in front of those. What I'm picturing is that 1 and that 1/2 that's in front of that one. So if I give you something like, I don't know, 13 pi over 14. Think about where 13 over 14 lies between those two. Is that over here, or is that between 1/2 and here, or is it bigger than that value? Okay? All right. Nope, we have two different ones here. And we'll talk about why I have two different ones in just a second. But let's handle the first one. The first one says to use a double angle to give me pi over 3. Now, when you're dealing with these, it's a little harder than dealing with 120 degrees. 120 degrees is just 2 times 60. But when you start having fractions, it can be a little bit more difficult. So you kind of have two options here. When you're using half and double angles, you're either going to double your denominator or you're going to half it. Well, let's choose the wrong thing. Let's put pi over 1.5. Well, if I multiply this by 2, I'd have 2 over 1.5. Does that get us to pi over 3? No. So let's double the denominator. And as surprising as it seems, doubling a denominator is actually halving it because you are multiplying it by 1/2. So doubling our denominator to multiply by 2 actually works. Because if I would do this multiplication, well, that's actually just 2 pi over 6, which equals pi over 3. So I strongly encourage you, even if you're really good at this, just in your head actually do that multiplication and make sure it simplifies to the original thing. It's such an easy thing to do, but you can catch big mistakes on a test. Now we're going to start asking ourselves a question. Is pi over 6 on our unit circle? Yes. So this is the proper one to use. So like I said, on your homework, it's not going to tell you which one to use. You need to plug it in and see if it's on a unit circle. If it's not, erase it and try the other one. So we have 2 times pi over 6. Pi over 6 is on our unit circle. Bam. That's the angle I need to plug in. The 2 just tells me to use one of the 3 equations. As a reminder, if we go back here, we have 3 separate ones to choose from. I don't care which one you pick. They're all the same. So at this stage, you need to just pick one of the 3 possibilities. And you can pick any one. Pick any of the 3. Pick any of the 3 identities. Identities. So I'll go where you want to go. Someone check out the 3, find your favorite one, and just let me know which one to use. They'll give you the same answer. Yeah, Andrea, sorry.
Cos squared minus sine squared.
Sure. That's actually one I put in my notes because it's the first one, right? But you can use any one of them. In fact, I encourage you, try another one while I do this one if you want to. Make sure they come out to the exact same thing. So we're using cosine squared. Well, we're going to put the angle pi over 6 in. And we're going to subtract sine squared. And we're going to go pi over 6 as well. The kind of nice thing about picking this one is you're going to create 2 fractions with the same denominator. So they're going to be pretty easy to push together. All right, so as a reminder, we're doing cosine pi over 6 squared. So that means first we find pi over 6, cosine of pi over 6. That's our first tick mark. So what's cosine of pi over 6? Yeah, radical 3 over 2, but we are going to square it. Well, if cosine's radical 3 over 2, that must mean that the sine of that same place is 1/2, and we're going to square that. And that's going to end up equaling 3 over 4 minus 1 squared is 1, 2 squared is 4. 3 minus 1 is going to be 2 over 4, which is going to equal 1/2. Is the cosine of pi over 3 1/2? Yes. Did it. We did it, guys. We found the exact value that we found on day 2 of this class. Nice job. Crushing it. All right. Check out cosine of pi over 3. Let's pretend you're on your homework. Let's erase this one. Just pay attention. Don't do what I'm doing, because I actually want to do pi over 8 for a specific reason. Let's say I ask you to do pi over 3. Well, if when using this one I have to double it, I must have to half it here, which means I'd be plugging in pi over 1.5. Is pi over 1.5 on my unit circle? No. So in your homework, if that comes out to that, you're like, oh, nope, can't use that one, have to use the double angle one. So like I said in the homework, it's not going to tell you which one to use. You need to take that first step, see if it puts it on the unit circle. If not, go back and try the other one. I will note, kind of like our last example, sometimes both of them work. So that's when I'm going to try to use the double angle. Okay. But anyway, we have, to erase this, we are going to go back to the pi over 8. Well, if I use the double angle one, that would be pi over 16. It'd be 2 times pi over 16, so double angle would not work here. But a half angle, we are actually going to multiply it by 2 to divide it by 2, which actually turns this into pi over 4. And pi over 4 absolutely works, because let's just do a little side note. Well, if I have pi over 4 over 2, if I wanted to get rid of the denominator, I'd multiply the top and bottom by 4, just to practice this skill, which would then equal pi over 8. We're good. Or you can just keep change flip. Okay, so we're good. Pi over 4 over 2 is the same thing as pi over 8. As a quick reminder, the only thing I really care about is the angle. The 2 is just going to lead us to one of our 3. It is your choice which one of the... Oh, no. I'm sorry. We're doing half angle. We only have one possibility, and that is that plus or minus. Remember, this is the exact same thing as the sine half angle, except for this time it's a plus. So we'll have 1 plus cosine pi over 4, and that'll be over 2. Pi over 8 is not on my unit circle. Navia, what quadrant would pi over 8 be in, though? It'd be in the first quadrant. It's pretty small, right? It's definitely smaller than pi over 2, so that's where we go, oh, that's in the first quadrant. So we have to use a little bit of intuition to go, oh, that's quadrant 1. So we're going to just use the positive again, because we're in quadrant 1. Okay, let's move forward. Hey, Tate. So we're going to have the square root of a positive value now. What I'm going to suggest you do is, what is the cosine of pi over 4? Shout it out. Yeah, radical 2 over 2. So maybe we can go, okay, that's radical 2 over 2. That's a 1, and that's over 2. Now, you can either push these together or you don't have to at this stage. You'll get the same answer. Either you push these two together, that 1 plus square root of 2 over 2, so you make this 2 over 2 and make it 2 plus square root of 2 over 2. Here's where it's nice to just know how to clear fractions. Because this is, oh, hey guys. So this is going to be the stage where I'm just going to multiply by 2. I'll multiply the bottom by 2 as well. Make sure you are distributing that 2 to both things. And you're just going to have the square root of 2 plus square root of 2 all over 4. Now remember, when you take a square root of a fraction, you're actually taking the square root of the whole numerator and the square root of the denominator. So the only thing that really simplifies it, it seems weird, but this is the simplified form of this. This is going to be 2 plus square root of 2 all over 4. Yeah, game. It would be over 2, yeah. How many times do you think people do that, though? A lot. So if you're one of those people that kind of make those little mistakes like that, you may want to take the time to write it all the way out instead of skipping. So we can go square root of 2 plus square root of 2 over square root of 4, and that's going to kind of help you not make that mistake. A lot of times when we make those big leaps is where we make those mistakes. So this, on your homework, the only way you can do this one is a double angle. The only way you can do this one is a half angle formula. Same thing with these last two tangent ones. The only one that was going to work on this one is going to be a double angle. The only thing that's going to work on this one is going to be a half angle. All right, so this one, it doesn't prep you this time. We just have to know we're supposed to use a double angle, so we're going to write tangent of 2 times something. And like I said, the easiest way to do a double angle is to actually double the denominator. You're basically multiplying it by 1/2. Yeah. It'd be 2 pi over 6. And that's our angle. We might quickly notice that 2 pi over 6 isn't on our unit circle. It's just because it's not simplified yet. But we'll leave it boxed in and we'll simplify. Don't do the multiplication. But we can simplify what I just boxed in. We can rewrite that as tangent of 2 times, and that 2 pi over 6 reduces to just pi over 3. And is pi over 3 on a unit circle? Yes. So before you're just like, oh, double angle is not going to work because 2 pi over 6 is not on my unit circle, make sure you simplify it first. And then you see if it's on your unit circle. So yeah, pi over 3 is definitely on our unit circle. So our double angle for a tangent is going to be 2 times that tangent of that angle, pi over 3, all over 1 minus tangent squared of that pi over 3. Pi over 3, out of the 3 choices, is the second best one, I guess, for tangent, because 1's the best. Yeah. Where does the square go? It goes right.
Before it goes tangent squared and then pi over 3.
Well, it actually means tangent pi over 3 squared. It means the same thing. So you could put it way after or not. Notationally, we put it in between so we don't accidentally square the pi over 3 before we take the tangent of it. All right. So tangent of pi over 3 is the second best of our tangent possibilities, and that's just square root of 3. So we have 2 square root of 3 over 1 minus square root of 3 squared. Well, the nice thing about the double angles, when we had the addition, we had to get rid of that square, but with the addition one, or the doubling one, we're going to get rid of it right off the bat, because square root of 3 squared is just 3. Try not to make it 9. It happens a lot. It's just 3. So we have 2 square root of 3 all over 1 minus 3. I'm going to run out of room, so I'm going to run to the right. We'll have 2 square root of 3 all over a negative 2, which is going to equal a negative square root of 3. If I look at my unit circle, is the tangent of 2 pi over 3 equal to negative square root of 3? Did we do that correct? Yeah, that's correct. So a lot of the ones on the homework, if they're already on the unit circle, you can quickly check to see if you did it correctly. Because we should already know tangent of 2 pi over 3 equals negative square root of 3. We should know what the answer is before we even start it. In fact, that's what I would do. I would look at the homework and see if is that already a value on the unit circle. If it is, I'll already have the answer in the back of my head. So if I get here and I get it, I'm like, good. If I don't, I got to go back and fix it. All right, tangent of 3 pi over 8. Now, if I was on the test or on the homework, I might think it's a double type problem. So I might type it, don't write this down. This is wrong. But I might, on the homework, write this as 3 pi over 16. Is 3 pi over 16 on your unit circle? Have you ever heard that value? No. So at this stage on your homework, you're like, nope, let's try something else. So the other thing is half angle. So half angle is we're going to put something over 2. Let me give myself enough room here. So we got to have something divided by 2. Well, to have it over 2, so if this is multiplying by 1/2, which doubles our denominator, for the half, we actually have to half our denominator, which is actually doubling your angles. Weird as that sounds. It's basically multiplying by 2, which halves your denominator. So that means we're going to have 3 pi over 4. And we should note that 3 pi over 4 is on our unit circle. All right, now if we go back to here, bless you. Bless you. I said you can pick any one of those 3. For cosine, all 3 are equal difficulty. For tangent half angle, all 3 are not equal difficulty. If I have a choice, boom, we're doing this one. So in class, I'm going to do this one. In your homework, you should choose this one. So the tangent of a half angle. Let's get there. So we're going to do that middle one. So we're going to do our 1. So we're going to do 1 minus the cosine of that angle I've boxed in, which is 3 pi over 4, all over sine of 3 pi over 4. I didn't miss anything, did I? No. Okay, so going through this one, we're going to have 1 minus, I'm going to note that 3 pi over 4, the 3 is 1 less, so we are in quadrant 2, which means cosine is negative and sine is positive. Anything over 4 for cosine and sine are always going to be square root of 2 over 2's. So that cosine of 3 pi over 2 is going to be a negative square root of 2 over 2. And that's going to be all over a positive square root of 2 over 2. I might look at a negative. Negative becomes a positive. Now, here might be the time that you clear your fractions. I have fractions within fractions. This is where it's nice to go, oh, if I just multiply the top and bottom by 2, as long as I do it correctly, it's going to be an easy job clearing fractions. I don't have to do keep, change, flip. So we're going to just have 2 plus square root of 2 over square root of 2. Don't have to deal with fractions, but I do need to clear out that square root of 2. So we're going to multiply the top and bottom by square root of 2. Making sure we distribute that square root of 2 to everything. We're going to have 2 square root of 2 plus 2 all over. Don't make this 4. It is just 2. We can break apart that fraction into 2 square root of 2 over 2 plus 2 over 2. Bless you. Which is actually going to reduce to square root of 2 plus 1, which typically we write as 1 plus square root of 2. There's nothing wrong with doing square root of 2 plus 1, but typically in like a book or something, you would note that. So that 2 goes to both of those fractions, and we have 1 plus square root of 2. All right, let's just look at the first problem together on our homework. So if you look at these, you have to decide whether you're using a double or a half angle, which means you have to try stuff. So So if I look at the very first one, the very first one says we're supposed to find the sine of pi over 8. Do I have that correct? Yes, okay. Let's say I'm going to try double angle first. That means I'm going to write this as sine of 2 times. When you double angle, you actually have to double your denominator. So that'd be the same thing as pi over 16. Do we have a pi over 16 on our unit circle? No. So at that stage, we either cross it out or erase it and go, oh, I should have used a half angle. Our half angle would be over 2, where we half the denominator. So we have pi over 4. Is pi over 4 on a unit circle? Yes. So we're going to use the half angle identity. My advice is just look at the given thing. So if I look at 15 degrees, is it better if I double it or I half it? Obviously, I want to kind of double that one. So just think about what's happening to it. Erase it if you make a mistake. If it's not in a unit circle, erase it and go back.